Hey guys, Andrew here with the Simplest. I have two Libre Renegade boards that I've been using for a little bit now, and unfortunately they didn't come with the heatsink, so I didn't want them to overheat. So what I did is I ordered a package of 8 heatsinks from Amazon along with some thermal paste, and I even have one of them running with a Raspberry Pi heatsink that has the thermal pad on it. So today I'm going to be testing the difference between them, finding out what the max temperature is without a heatsink, putting a thermal pad heatsink on one of them, trying it out, and then I'm going to try the thermal paste and we'll see what kind of differences we get. But first, the intro. So here I have one of my Libre Renegade boards running without a heatsink, and just basically has a basic install of Debian. And the only thing I really had to do was enable the temperature monitor, which is right here, and the CPU utilization monitor, which is right here. It's kind of hard to see, and I tried to blow it up, but unfortunately it wouldn't let me zoom in. The only other thing I really had to do was install sysbench, which can be done by typing sudo apt-get install sysbench. And what that's going to allow me to do is max out that CPU and really put some heat to it and see where we get. So I already have it installed. So as we can see right here, we have it idling right about between 45, 50, right about 50 degrees or so. It is kind of utilizing a little bit just because I'm on it. But it's about idle right now. So what we're going to do is I'm going to use sysbench to run the CPU. So what we're going to do is we're going to type sysbench test is going to be the CPU, because you can also use a GPU test on this. We're going to do CPU max prime equals, we're going to start with 20,000. And what that's going to do is that's going to factor prime numbers all the way up to 20,000. And we're going to do num tech threads equals 4. This is a quad core processor, so I want to be able to make sure to use all the cores, so we're not just using one core. And we're going to type run. And we're going to let this run, and we're going to keep an eye on this temperature up here. And as we can see, it's running 4 threads, and that thing jumps up. Here's the 100% utilization, and we jump up to about 64 degrees. And that took about 6.6 seconds. So just out of curiosity, seeing if maybe we change the, hit the up arrow, and we're going to go back here, and we're going to give this a shot with 35,000. And we're going to run that again. See if running it a little bit longer actually gets us a little bit higher. There it goes. And I don't really see it getting much higher. That could be due to throttling. Oh, there we go, 65. Looks like we went up to 65 that time. So pretty good baseline. So we got a baseline of right around 50 degrees idle and 65 when running with 35,000. So what I'm going to do now is I'm going to go ahead and switch out with my Renegade board that has the Raspberry Pi heatsink with the thermal pad on it. We're going to do the exact same test, and we're going to see what kind of differences we get. Alright, so I got my other Libre Renegade board out, and I put the same SD card in there. So what it is this is right here is the Raspberry Pi heatsink that comes with it. All it is got a thermal pad on the bottom of it that you just peel off, you stick it on the CPU. So we're going to go ahead and run the exact same test and kind of see where we're at. First of all, idling. It's been idling right at about 45 degrees. It's running at 47 now. So a couple degrees cooler. If you remember the idle temperature of the CPU that did not have the heatsink on it was already at 50. So we're looking at 45, 47 idle temperature. So I'm going to go ahead, and because I have the same SD card, I'm just going to hit the up arrow. And here we are with the test CPU prime number. We're going to start out with 20,000 again, and we're going to do threads 4, and we're going to run it and see where we go. So that is started. You can see the utilization go up to 100%, looking at about 60 degrees. So not bad. Peaked out right at 60 degrees. Didn't see it get any higher than that. So what I'm going to do now is simply just hit the up arrow, if this thing will work with me today. Tech problems, right? There we go. We're going to scroll over, and I'm going to change this to 35, and we're going to run it again. See if we can get up any higher than 60. Looks like I saw the max number that I saw pop up was 62. So we got about a 3-degree drop between the no heatsink and the Raspberry Pi heatsink. I'm not really impressed with it, but it does provide a couple degrees cooler. So what I'm going to do now is I'm going to go ahead and put the other Raspberry Pi back on, and I'm going to go ahead and fit this heatsinks that I got from Amazon with the thermal paste, and we're going to test it out again. Alright, so now I've got the heatsink fitted with the thermal paste, as you can see right here. And I don't know if you can tell from the video, but this heatsink is actually quite a bit taller than the other one. And I've let it run for a few seconds, and so far I have not seen this thing get above 40. It's been idling around 35 or so. We're at 36 right now. There's that 40 spike that I was just talking about. Drops back down. So we're looking at, I'm going to go ahead and call it 40-degree idle. Well, wait, now we're at 42. So I'm going to go ahead and call it a 40-degree idle. Peak of 42 so far, but I'm going to go ahead and leave it right there. And I'm going to go ahead and do the same test again. Bench test equals CPU. CPU max prime 20,000 num threads equals 4 run, and here we go. Typoed. Sys bench. All right, here we go. Wow. All right. So 51-degree max. That was our peak. I'm gonna go ahead and run this again with that 35 and see where we get, but I don't see it getting much higher than that. Definitely seeing a huge difference between that pad and thermal paste. 52, running right about 50, but 52. So we peaked at about 52 degrees. So that right there is a 10-degree difference using thermal paste versus that thermal pad. Yeah, just for fun of it, I'm gonna do a bigger test. Let's see here. We did 20,000. We did 35,000. Let's do 100,000. Let's see what this thing can do. I think that's 1,000,000. Nope, that's 100,000. All right, let's go ahead and see what this thing can do. Let's see how long it takes to factor up to 1,000,000 prime numbers. This is probably gonna take just a little bit of time, so I'm gonna let this thing run. All right, so it took us 57 seconds to factor all the way up to 100,000, and our max temp that I saw during that test was 56 degrees. So we're looking at a 6-degree drop, and we factored almost three times the amount of prime numbers, or the 3 times to the max. So I'm going to go ahead and say that I really like this thermal paste a lot better than those thermal pads. If you're doing CPU intensive processes, this is definitely going to help keep those temperatures down. The only thing I will say that I don't like about using this thermal paste is the CPU tends to move around, or the not the CPU, but the heatsink tends to move around, because unlike the thermal pad where it's just glued, or not glued down, but stuck down with that thermal pad, this thermal paste is not really designed for this. It's designed for CPUs where they're actually locked down with a cooler of sorts, whether it be air cooled or liquid cooled. So it does move around a little bit, so you're gonna have to make sure, if you are using thermal paste with these heat sinks, you're gonna have to make sure to secure it in a place where that it's not going to move around. So that's all for today's video. Nice and short. Just wanted to throw up a couple of tests. Hit me up in the comments. Let me know if there's any specific kind of test that you want me to do. Also, leave me some feedback. Let me know what I can do to better generate content for you guys. And until next time. All right. I realize that a lot of people were probably gonna, complain about the size difference between these heat sinks. So I wanted to make sure to do one final test. What I did is I took that Raspberry Pi heatsink and I rubbed off and peeled off all of the thermal paste, got it nice and cleaned up, and ended up reattaching it with just thermal paste. Same heatsink as before with the thermal pads, but I just put on the thermal paste to see if there is any difference. I'm actually kind of curious myself, and I knew that somebody was going to comment that well, the size of the heatsink will make a difference. So you're absolutely right. So this thing's been running for just a few minutes to let it kind of idle out. I've been sitting right at about 45 degrees, which is the same as the heatsink with the thermal pad. So I will give you that. The idle temperature is about the same. So what we're going to do is I'm going to go ahead and rerun that test again. As you can see, I still have it up from when I ran the 100,000. And I'm going to go ahead and run that 20,000 test and see what we get. All right, so it looks like we peaked out at about 55, so it is actually a little bit warmer. It's still not quite as warm as the thermal pad. The thermal pad, if you remember, was 60 for the 20K test. So I'm going to go ahead and run that 35K test again, and we're going to see if we get up there. Just a reminder, the Raspberry Pi with the thermal pad for the 35K test was 62 degrees, so let's see what we get. Looks like we went at 57. If I remember seeing that correctly, I'll put the correct number down below. I kind of missed it. I believe it was 57. So still 5 degrees cooler just switching out from that pad to paste. So the heatsink, definitely the size of it made a difference. It made about a 5-degree difference, and then the other 5 degrees was that thermal paste versus the thermal pad. So once again, in conclusion, I am a fan of this thermal paste a lot more, and other reviewers have done tests as well, and shown that thermal paste is a lot better than thermal pads. Ideally, in these little single board computers, you're probably not going to really need that big of a difference, so those thermal pads probably work really well, but I just wanted to kind of see what the difference was and put it to use. Thanks, guys.